first lesson of new content being taught. Today's lesson is going to be on factors, multiples and primes. It may not be completely unfamiliar to you because you may have come across this in primary school. The way this lesson is going to work is I'm going to go through a series of examples and there'll be exercises for you to try. So you need to make sure that you've got a pen and some paper so you can try the examples and work through the exercises, and just be ready to pause the video when I ask you to. Lastly, on Show My Homework, what I'll do is post the approximate timings for each of the sections of the video, and this will allow you to jump back and forth as needed to make sure that you get maximum benefit from this lesson. So this is your Do Now task. I only want you to pick red, yellow or green to complete. No calculators. Have a go. Pause the video now. So here are the answers. Pause the video now so you can mark your work. Okay, so there are some keywords that you need to know today, so make sure you pause the video, and what I would like you to do is copy into your books or onto paper these three definitions of factors, multiples and prime numbers. It's really, really, really important that you memorise these and you remember the difference. So pause the video now, make sure you copy this down. Okay, so the first example I'm going to go through is explaining factors. So we want to list all the factors of 42. To do this, what we're going to do is list pairs of numbers that multiply together to make 42. This is the easiest way to make sure that we cover everything. So 1 times 42 is 42. 1 and 42 are always factors of the number if it's 42, 1 in itself. 2 times 21 is 42. 3 times 14 is 42. 6 times 7 is 42. Okay, so the way I've worked through this is I usually use 1 is always a factor and the number. If the number's even, we know 2 is always a factor, so we can try dividing 2. Then I would try dividing 3 into the number, then 4, then 5, then 6, then 7, etc. As you might notice, by the time you get to 6 times 7, there are no numbers between 6 and 7, therefore we know we have completed all the possible factor pairs. So the last step is just listing the factors, because it does say list in our question, so we just write them in order of smallest to biggest: 1, 2, 3, 6, 7, 14, 21 and 42. Okay, so on the right hand side there's one for you to try. So the question's similar: list all the factors of 63. So just pause the video and work through this question, and then I'll go through the answers in just a moment. So just pause the video. Okay, so hopefully you've tried that question. So listing out all the pairs of numbers that multiply together to make 63, we're going to have 1 times 63, 3 times 21, 7 times 9. 8 is not a factor of 63 because 63 is not an even number. So then we just list out all of our pairs in order of smallest to biggest. So we'll have a list that looks like this: 1, 3, 7, 9, 21 and 63. So if you need to make any amends to your workings, do so now. That's fine if you have. Part of it is working through these questions and not being afraid to make mistakes. Okay, so it's practice time now. What I would like you to do is work through these questions, so you're going to need to pause the video. What we're looking to do is read each of the statements and decide whether they are true or false. So think really carefully about the order of this question that it's asking. So 6 is a factor of 3. So just think about that. Is it possible for 6 to be a factor of 3? So just pause the video, work through these questions and then mark your work in a minute. Okay, so these are the answers to all the questions. Is 6 as a factor of 3 is false, because 6 is bigger than 3, so it can't be a factor of 3. 3 is a factor of 6, that's true, because 3 is smaller than 6 and 3 divides into 6. And you get a whole number out. 3 times 2 is 6 and so on. So just pause the video, mark your work. Okay, the next example we're going to go through is how we find multiples. So in our key definitions, we said multiples were just times tables. So if we want to list the first 5 multiples of 3, we're just going to go through our 3 times table. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. It's very, very simple. So multiples, we're talking about times tables. Okay, so now it's your turn. I want you to list the first 5 multiples of 7. So just pause the video, list the first 5 multiples. Okay, so hopefully your list will have looked like this. You can write 7, 14, 21, you can write it as a list. I've just written it out as a column so that you can see the numbers quite clearly. So mark your work, make any amends if you need to. Okay, so it's your turn now. We're thinking about multiples and looking to see whether we think these statements are true or false. So our first statement is 4 is a multiple of 8. So what you're thinking about is 4 in the 8 times table? Note that's different from 4 being a factor. So just pause the video, work through these questions, write whether you think they are true or false, and then we'll mark them in just a moment. Okay, so the answers are up on boards, so please just mark your work. 4 is not a multiple of 8, 4 is a factor of 8, but our first number in our 8 multiples is going to be 8 itself, so it's already too big. 8 is definitely a multiple of 4 because our 4 times table goes 4, 8, 12, 16, etc. Okay, so the next section is looking at prime numbers. Remember, our definition is a prime number. These have exactly 2 different factors, 1 and itself. Okay, so 1 is not a prime number. You need to remember this. 1 is not a prime number. It only has 1 factor, which is 1. So in this exercise, what I'd like you to do is thinking about prime numbers. We want to find factors of the numbers in the column. So although it says prime number, we're deciding whether this statement is true or not. So we start with 10 and we're going to list out all the factors of 10. So we would have 1, 2, 5 and 10. And we would decide then whether it fits our definition of exactly 2 different factors, 1 and itself. So 10 has 4 factors, which means it's not a prime number. So you're just going to work through these 3 columns, listing the factors and then deciding whether that number is a prime number or isn't. So just pause the video and work through these questions. Okay, so the answers are 10 is not, 9 is not, 8 is not, 7 is. So 1 and 7 are the only factors of 7. Therefore, we'd say that's a prime number. So this is quite good. If we look down our list, we can see 2 is the only even prime number, and it is the first prime number in our list. No other even numbers after 2 are going to be a prime number because they always have 2 as an additional factor. Okay, so now it's your turn. So using this grid, if you're able to print it out, great. If you can't, what I would suggest is you write down the numbers that are prime numbers. So we said 1 is not a prime number and 2 is our first prime number. Therefore, we can say any other even number is not a prime number. What I would like you to do is just circle or write down all the numbers between 1 and 100 that are prime numbers. So just pause the video now and work through that. Okay, so what you should have ended up as a list like this. So our prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, etc. Okay, so all the numbers in purple are your prime numbers between 1 and 100. Okay, now we're going to look at how to find the highest common factor. So what's the biggest number that's common to both 20 and 8? So first of all, for 20, I'm going to list all the factor pairs of 20. 1 times 20, 2 times 10, 4 times 5. That's my list. And then I would write it below 1, 2, 4, 5, 10 and 20. Then I'm going to list all the factors of 8. So I've got 1 times 8, 2 times 4, and that's my list. So 1, 2, 4 and 8. And then all we're going to do is look at both lists, and we're going to see that the highest number that appears in both lists of factors is 4. So we can say the highest common factor, or HCF, is the number 4. Okay, so just pause the video and have a go at this question on the right and allow you to make some notes on the worked example. So just pause the video and have a go at this question on the right. Okay, so we're going to list all the factors of 20, we've got that on the left hand side, and now we're going to list all the factors of 15. 1 times 15, 3 times 5, that's it. Then we're going to look at both of our lists of factors and look for the number that's biggest that appears in both, and if we do that we'll see that 5 is the biggest number that appears in both of those lists of factors. Okay, so now I'd like you to have a go at these questions. We want to work out the highest common factor of these number pairs, 12 and 1. Sometimes the highest common factor is going to be 1 as a hint, and that's perfectly okay. So just work through these questions and work out what the highest common factor is going to be. Okay, so there's another set of questions. Keep going, pause the video, work through these questions, and then mark your work in a minute. Okay, so answers for the first section. Answers for the second section. Note where there's ... all that means is the highest common factor between the two numbers is going to be 1. Okay, so now we're looking at lowest common multiple. This works a little bit differently. So this time we're going to list our 2 times tables. So the 20 times table and 8 times table, we're going to list those and look at where they intersect. So 20 times table, 20, 40, 60, 80. I'm guessing to where I need to stop. I might need to extend that times table if my numbers don't intersect in both lists. Okay, my 8 times table, 8, 16, 24, 32, 40. Okay, so I'm going to stop and I'm going to look at both lists and see if there is a number that has appeared in both lists. That is going to be my lowest common multiple. If I look at those lists, I can see that 40 is the number that appears in both lists, and that's the first time they have intersected. Therefore, we can say our lowest common multiple is the number 40. Okay, so I'd like you to have a go at this question on the right. So just pause the video and follow the method that I've just shown you. Okay, so we've got our 20 times table. I've done it up to 80. Remember, you can extend your list as needed. I've just done the first 4 for now. Then my 15 times table, 15, 30, 45, 60. I've done the first 4. If I look at my lists, 60 is the first time these times tables meet each other. Therefore, we can say the lowest common multiple of 20 and 15 is 60. Okay, I'd like you to have a go at these questions now. We're looking at the lowest common multiple of these 2 numbers. Okay, so remember we're listing out our times tables and comparing them, and then we're working out where they first intersect. And this is the second part of the questions. Keep going and mark your work in a minute. Pause the video if you need to now. Okay, so just mark your answers. Lowest common multiple of 12 and 1 is 12, 12 and 2 is 12, 12 and 3 is 12, 12 and 4 is 12, and so on. But 12 and 5 is bigger, so just make sure you're being careful, being very methodical, listing out your work. And the second set of answers, just pause the video and mark your work now. Okay, so that's it for the lesson today. I hope that you've got lots of work done and you've made some progress. So I'd like you to have a go at this reflection task now. So one question you still have, I'm still not sure on, or I don't understand why. On the second layer in the yellow boxes, 2 things you've learnt today. So I've learnt that or today I've discovered, I now know. So just looking to complete those sentences. And on the final level, with the 3 boxes in pink, today I used the fact, I used knowledge I already had, such as, so 3 things you already knew that you used today. Just reflecting on your learning. Just pause the video and then you finish the lesson for the day.